These rings are variations of the same prototype. The gem profile varies. Some are rounded, others oval. The shank section varies. D-shape, or knife. However, only one prototype has been modeled, and each variation was obtained in a few seconds. We could generate as many variations as we would like. If it is not magic, how is it done?
Hello, this is a new presentation on parametric CAD for jewelry. We continue in this strange time of lockdown due to the coronavirus. So we have to stay in our home in a village near Barcelona called La Llacuna. It's an almost medieval and quiet place where you can find some inspiration for your design. Remember, on your next vacation in Spain, not everything is Mediterranean beaches. Remember to visit the unlined villages. So in this place and in these times, we can take advantage to learn about this new technology, the parametric CAD applied to jewelry. At the beginning of this video, we have presented a case, and now we are going to see how it is solved. But I leave you with Helen's explanation. She's not my robotic assistant, I'm afraid. I'm her human assistant because she recites the subtitles I have to write to her.
Back to our variations. Let's check how the size of the gems affects certain dimensions of the ring. In this ring the three rounded gems are wider. In this ring the oval gems are narrower. Let's see the dimensions in the top view. Oval gemstones extend to over 12 mm. Rounded gems exceed 16 mm. We are going to alternately hide the rings to see the changes in the shank. Check the changes in the front view. The shoulders are modified while the rest of the dimensions of the shank remain the same. Obviously the claw sizes also vary. Let's see these changes with the ghosted display. Now it's time to reveal the secret. Let's discover the tool to create these variations.
Open your eyes. Look around you. It's a beautiful
Back to our example. Let's make a fourth variation.
Open your mind.
This is our parametric tool, Grasshopper. First we show a red preview with the last version parameters. We hide the other versions except the last one. Now they are both the same. Let's change some dimensions, the rest will remain the same. We start with the most common modification, the finger size. We check the size increase in the right view. Now we are going to shrink the central diamond, making it oval. We shrink the side diamonds, making them also oval. Automatically the collets have shrunk and the shoulders have come closer. Now we increase the shank thickness. A zoom here will allow us to explore the following change. We will modify the profile of this curve. First we increase it in the Z direction. Now we sharpen the knife profile. And we are going to stop here, but we could modify many other parameters. Once we are happy with the preliminary version, we will export it to Rhino. We hide the grasshopper preview. And here it is. In less than 2 minutes we have created a new variation. How long would it have taken without parametric CAD?
When you're surrounded by darkness,
But,
open your
something
eyes.
missing.
Look around you.
Let's explore
It's a
grasshopper's
beautiful
guts.
life. Don't waste time.
We maximize
Open your
grasshopper.
mind. Have no regrets.
That is the general diagram.
Paint the sky your favorite color.
Each of these modules is a cluster of operations. This cluster makes the ring shank. It contains 2 clusters. The first one makes the curves.
The sky.
We display the second. It makes the surfaces. These are all the connected operations. When we modify an input, each component transmits its outputs. Let's check a component, the sweep 2 rails. This is the input of the first rail. This is the second. The section of the surface. Let's check the output in Rhino. We have a provisional shank surface that will later be corrected. Let's see the end, where all surfaces are joined. The join and cap holes components. Preview of the shank closed surface after executing the cap holes component. So it was not magic. The job of the parametric designer is to program this diagram. It is laborious, but, once finished, we get variations of the prototype easily. So if the parametric CAD generates immediate variations, but it requires a long programming work. When is it worth using it?
Yes, that's a question. We can think in 2 extreme cases. First, the case of a single model without requiring variations. Okay, here we don't need parametric CAD. We would choose conventional direct CAD. Second case, prototype design that requires some variations. There are a few loops here.
When you're surrounded by
We would
darkness,
almost always choose parametric CAD.
look
For
around
intermediate cases, the turning point in favor of the parametric CAD
you. Don't waste
depends on the characteristics of each design. For some it may be 3 variations, for others 5, 7, it depends. So, if you have a project in mind and want to evaluate both options, contact us. We will be happy to advise you on the best option. And that's all. Have a nice day and remember, keep safe.